Hey guys, welcome back to my YouTube channel Meant Edophilia. So in our previous class we started with 1D motion and we were mostly focusing on the hints, the important models of questions and the tricks that you need to know to approach any question on this chapter. So let's continue. We were looking at the differentiation related questions. So what is the physical significance of differentiation? Just to find the slope of the graph. And for integration, the physical significance is to find the area bounded by the curve. So from x we can find v, and from v we can find a by differentiation. Similarly, the reverse process, acceleration to velocity, we have to integrate. Similarly, to find displacement from velocity, again we need to integrate. So this is a basic idea that you need to know for solving problems related to differentiation and integration. So now let's look at a very important model of question. So this important model is that they will give you the xt relation and they'll ask you the distance covered by the object or the body. So finding the displacement is easy, but finding the distance is tricky, and that involves a catcher. So I will first give you the question so that you'll understand better. The question goes like, position of a body moving along x-axis is given by x is equal to t square minus 4t plus 6 meters. Find the distance traveled in time equal to 0 to 3 seconds, and these are the options. So note that in the equation given there is a minus sign. Okay, so that means that with increase in time the distance somewhere at some point it is getting decreased, that is it is coming back. So this means that the displacement and the distance, they are not equal. Okay, so what most of the students will do is that they will substitute t is equal to 0 in this equation, and then they'll substitute t is equal to 3 in the equation, and then they will subtract final displacement minus initial displacement, and they will find the answer and they'll shade the option. That will lead to a blunder. That's not the method. That's not correct. In the question they are asking the distance traveled and not the displacement. So first step is to check if the particle is coming at rest, okay, coming to rest at any time between the given time interval. Okay, so if the particle is going to come to rest, that means velocity is reducing to 0. So substitute, first find the equation for velocity from the given xt relation by differentiating with respect to time on both sides. We get v is equal to 2t minus 4. So then substitute v is equal to 0 to find at which time the body is coming to rest. So we get t is equal to 2 seconds. So at second, okay, at 2 seconds the body is coming at, okay, it is coming to rest. So we need to find the distance between 0 to 3 seconds, but at the second the body is coming to rest. So from the equation v is equal to 2t minus 4, we can also find the acceleration by further differentiating with respect to time. So from this we find acceleration is 2 meter per second square. So velocity v1, that is at time, is equal to 0 second. What is the velocity? Substitute t is equal to 0 in the velocity equation. We get 2 into 0 minus 4, which is minus 4 meter per second. So what do we observe here? Acceleration is 2 meter per second square and v1 is minus 2 meter per second, 4 meter per second. So they are of the opposite sign. This denotes that the body is slowing down, which represents deceleration and not acceleration. So hence the body starts with certain velocity, the velocity is decreasing, and finally at the second the body is coming to rest. So v1 is minus 4 meter per second, v at t is equal to 2 seconds, that is 0, yes, and what is v at 3 seconds? Substitute at the third second 2 into 3 minus 4, which gives us 2 meter per second. So now you notice that at third second it is 2 meter per second and the acceleration was is minus 4 meter per second. Again it is the opposite direction. So now I'll tell you the correct method to approach this question. So first step, okay, what are the steps involved in finding the distance if velocity is given as a function of time or if distance is given as a function of time? Okay, first step is to find t at which velocity becomes 0, the time at which the particle is coming at rest. Say this time is t naught. Second step is to find S1, displacement, for 0 to t naught time interval. Then S2 for t naught to t time interval. Okay. Then the distance is nothing but modulus of S1 plus modulus of S2. So even though you get S as negative, okay, S1 and S2 as negative, we do not consider the sign. We are adding the absolute values because we are dealing with distances. So how can S be found out? It can be found out by integrating velocity. So the mistake committed by most of the students is simply adding S1 and S2 without taking their modulus. Okay, so that is the mistake. So don't do that. So if in the same question displacement is asked, okay, what will you do? You again take the modulus of S1 and S2, but here we subtract it, not add it. S1 is the distance travelled in 0 to 2 seconds here, that is till the body comes to rest. Then S2 is the time is the distance travelled from 2 to that is second to third second. So since acceleration and velocity are in opposite direction, the speed is decreasing. Okay, so it is returning back to the along its original position. So that is S2. So the final displacement is the one which is S. It is between the initial and final points. So the first step in which we got the equation of velocity, we can integrate to find the equation of S with respect to t. So integrate, what do we get? 2t square by 2 minus 4t. That leaves us with t square minus 4t. So this is the expression of S. So now we have to find S1 and S2. S1 is between 0 to 2 second and S2 is between 2 to third second. So simply substitute t is equal to 2 and t is equal to 0. The normal integration with limits. So next part for S2, substitute t is equal to 3 minus substitute that for t is equal to 2. So what do we get? We ultimately get 4 minus 8 within the modulus plus 9 minus 12 minus of 4 minus 8. Everything is within the modulus. So finally we get 4 plus modulus of minus 3 plus 4. We get 4 plus 1. Okay, there's a modulus sign. So we get 5 meters. So this is the final answer. So this was all about solving problems on differentiation and integration. Now let's look at the applications of equation of motion. So here again I'll only tell those hints that you require to solve problems and not into the detailed conceptual part. So first case is when the horizontal motion where acceleration is constant. In such cases, the average velocity can be written as initial velocity plus final velocity by 2, the average velocity. And the distance is nothing but average velocity into time. So displacement is u plus v by 2 into t. Okay. Next is finding the displacement at nth second. So Sn is equal to u plus a by 2 into 2n minus 1. This is a popular equation. By now you all must have known this. Similarly, at the mth second you can write the same way. U is u plus a by 2 2m minus 1. So they will give you the distance, the displacements at the nth and mth second, and they will ask you to find the acceleration. So how will you do it? Simple. It is Sm minus Sn by m minus n. That will give you the acceleration. Next type of commonly asked problem is the velocity of train when it is at the midpoint. That is when its midpoint crosses the pole or a tree or whatever. So is a previous year question based on this. So I would like to discuss this concept also. So let's say the length of the train is L and it crosses the pole. That is the initial part of it crosses the pole with velocity u, and the midpoint crosses it with velocity v dash, and the end of the train crosses the pole with velocity v. So we are required to find the velocity at the midpoint, that is the midpoint's velocity, that is v dash. So from this we can write the basic equations of motion. That is, for the first case, by using the standard equation v square minus u square is equal to 2as. From this, the first case you can write v dash square minus u square is equal to 2a. S is nothing but L by 2 because the midpoint is crossing the pole. So similarly, look at the second case in which the end crosses the pole starting from the midpoint. So here you can write v square minus v dash square. V dash square becomes the initial velocity in case 2 is equal to 2a L by 2 again. So on solving both the equations, the RHS are equal, so you can equate the LHS. So we get v dash square minus u square is equal to v square minus v dash square, and ultimately we get v dash as under root u square plus v square by 2. So this is the velocity at the midpoint of the train when it crosses a tree or a pole or whatever. So this question was already asked in one of the previous year papers. So how else can this type of question be asked? A little modified version is this. They might ask you to find the fraction of the train, and they might ask you to find the velocity at that fraction of the length of the train. For example, I'll give you a question. The speed of the train at the pole we required to find if it covers 2/5 of the distance between consecutive poles. So what do we need to find? We need to find the speed of the train at the pole when it covers 2/5 the distance between consecutive poles. So using the same method as above, you can find this answer as well using the equation v square minus u square. A smarter approach to this question will be to find the logic. When I said midpoint, the fraction was 1 by 2, isn't it? So the denominator was 2 here, okay? But here it is 2/5. So the answer also will have the same under root, the same 5 in the denominator. Are you able to understand? So these are all some tricks which you can use to derive the answer in just a single step. So now look at the numerator. It is u square plus v square since it was the midpoint. Okay. So the term that is the coefficient of v square will be always from the question. Remember. So it is 2v square. Okay. And the coefficient of u square is 5 minus 2, that is 3u square. Just like that in the midpoint case. In midpoint case, we had the fraction as 1 by 2, so the denominator is 2, and v square is always from the question, that is 1 by 2. The numerator is 1, so it is 1 v square. But for u square, what do you need to do? Subtract numerator and denominator. 2 minus 1 is 1, so it is 1 u square plus 1 v square by 2 and whole under root. Okay, that was for midpoint. For some fraction given like 2 by 5, there is same under root by 5. Okay, that is constant, that's not going to change. And for v square, the numerator will follow here as well, so it is 2v square. And for u square, the coefficient is 5 minus 2, which is 3u square. Easy, isn't it? This is how you can find the answer to this question without using motion equation, without even lifting your pen, you can find the answer. Now let's move on to the next set of tricks that I am here with. That is law of odd numbers, a very popular trick that every NEET aspirant might be knowing by now. So this is used when the initial velocity is 0 and acceleration is constant. So law of odd numbers is nothing but the ratio of distances for equal time intervals follows the odd number ratio. Remember, it is for equal time intervals. So S1 is to S2 is to S3 is nothing but 1 is to 3 is to 5 is to 7 is to 9 is to 11 and so on. So what are the two important conditions? Initial velocity is 0 and acceleration is constant. So this might seem really simple. So for that to test your knowledge and understanding, I'll give you a question which goes like, a body starts from rest and then travels with acceleration 4 meter per second square along a straight line. Find the displacement of the body in the fifth half second. So understanding this term, fifth half second, is important. So 0 to half second is first half second, half to 1 second, second half second, 1 to 1.5 second is the third half second, 1.5 to 2 second is the fourth half second, and 2 to 2.5 second is the fifth half second. So the body is starting from rest and it is traveling with a constant acceleration. So what is the ratio of the displacements for equal intervals of time? That is, each time interval is half second, so they are equal. So it will be x, 3x, 5x, 7x, 9x and so on. So x we know from the standard equation, x is equal to ut plus half at square, u is 0, so x will be half at square. So x is nothing but half into 4 into 1 by 2 the whole square, which is 0.5 meters. So what do we need to find? We need to find the displacement in the fifth half second. That is nothing but 9x. So 9 into 0.5 or half is nothing but 4.5. So now let's move on to the next type of most commonly asked, most frequently asked type of problem, which is the tap problem. So let's understand with a question. Water drops are falling at regular intervals of time. The sixth drop begins to fall when the first drop just strikes the ground. Find the first subdivision, height of the second and the fourth drop from the ground. So let's draw the situation and understand the scenario here. So there are 6 drops first. Okay, it begins to fall when the first drop just touches the ground. So they have given regular intervals of time, which means time intervals are equal. So the ratio of the distances are x, 3x, 5x, 7x and 9x, isn't it? And the height, total height, yeah, so the total height that is between the roof and the ground is given, okay, it's 20 meter. And since these drops are falling under the action of gravity, acceleration is the acceleration due to gravity, that is 10 meter per second square. So first subdivision, we are required to find the height of the second drop, which is 9x, and fourth drop, which is 9x plus 7x plus 5x. And how will you find x? We can find x by equating 20 to x plus 5x plus 7x plus 9x plus 9x as is equal to 20. So from that we get x is 4 by 5. Okay. So 9x is 9 times 4 by 5, which is 7.2 meters. Similarly, the distance from fourth drop is 21 into 4 by 5, which is 16.8 meters. So now let's look at the second subdivision. So find the time interval between consecutive drops. So they have given the drops fall at regular intervals of time. We are required to find that time interval. So we know x is equal to half at square, isn't it? It's just starting from rest and there is a constant acceleration. So x is equal to half at square. So x, we just found it out that it is 4 by 5, which is half into, we get t as 2 by 5 seconds. This is one method to find, or you can also do it as t is equal to, that is by equating 20 the total height into 5t square, because it's 5 equal intervals. So half into 10 into 5t the whole square. That also gives t as 2 by 5. And you can also do this method. We know this equation, t is equal to under root 2h by g. Using that also you can find. Using anything you do, you always get t as 2 by 5 seconds. So yeah, this was it about understanding tap problems. So the next part of this chapter deals with sign conventions. So the frequently asked theory questions on sign convention is that if acceleration is positive, velocity must increase. So tell me, is this statement true or false? So always remember, acceleration and velocity, if they are of the same sign, then velocity increases. That is, it is acceleration, it is speeding up. And if acceleration and velocity, they are of different the signs, they are of opposite signs, that means velocity is decreasing. Understood? So what does this mean? Either if acceleration is positive or negative, it can imply it is acceleration or deceleration. So the sign does not depend on whether the velocity is increasing or decreasing. So always keep this in your mind. It all depends on whether the signs of acceleration and velocity are same or opposite. So this statement is definitely false, because they've given velocity must increase if acceleration is positive. No, it is false. Now I'll give you the second statement. If acceleration is positive, velocity may increase. So this statement is true, because if acceleration is positive and say if velocity is also positive, then velocity increases. So it is true. But if acceleration is positive and velocity is negative, opposite signs, so velocity decreases. But there is the word may over here. So this may means there are either chances, positive or increases or decreases. Yes, so the given statement is true. So be very careful with the words. It's just a single word, must and may, which is going to make a lot of difference in your marks. Okay. So when it is graph based, that is ST graph, remember when it is a downward graph, downward bowl, it means that acceleration is negative and velocity is negative. When the same xt graph has an upward curve, this implies acceleration and velocities are positive. So now let's move on to the central topic, which is vertical motion or motion under gravity. So we know there are standard equations used here, like v is equal to gt, h is equal to half gt square, v is equal to root 2gh, t is equal to 2h under root 2h by g. So these are the standard equations that all of us will use. So now let's directly move on to question solving, as that is most important. First question, if a ball under free fall takes time t to cover h by 2 distance, find the time taken to cover the remaining height. So we know that the total height is h and the first half is covering in time t. Okay, so total height, we know the formula, the total time of flight can be written as under root 2h by g. And t from the question we can write under root 2 h by 2 by g. So this gives us under root h by g. So what is the remaining time? It's nothing but the total time minus t. So under root 2h by g minus under root h by g, which gives us under root 2 minus 1 into under root h minus g. So let's move on to the second question. A ball is released from height h. After t1 seconds, it momentarily stops and is released immediately. Find the time, the further time it takes to reach the ground. So there is a ball which we are releasing from the top from height h, okay, and at some height it comes to rest at after covering say distance x, okay, it comes to rest at t1. So it starts with initial velocity 0 and then it's coming to rest momentarily at some point, and then again immediately it is released and it reaches the ground. It takes t2 seconds and the distance is y. So the total height h can be written as x plus y, and x we know it is half gt1 square, and y is also half gt2 square because initial velocities in both the cases is 0. So h is equal to half gt1 square plus t2 square. So we are required to find the remaining time, the further time it takes to reach the ground, which is t2, which is under root 2h by g minus t1 square. So next I'll discuss about an important trick that you should know. The ratio of time intervals by the body to fall through successive equal distances, that is t1 is to t2 is to t3 so on, is 1 is to root 2 minus 1 is to root 3 minus root 2 is to root 4 minus root 3 and so on. So are you able to understand? 1, 2, 3. That's the pattern it follows. So this is the ratio of the time intervals for equal distances it covers. Whereas for law of odd numbers, that was ratio of distances for equal time intervals. So note the difference. This is one thing that you should keep in your mind. So next type of problem that is most repeated is dropping two balls from a tower. Okay, so let's look at that problem. A ball is dropped from a tower of height 125 meters. 2 seconds later, another ball is released with velocity u. Find u so that the two balls reach the ground simultaneously. So there are two balls, ball A, ball B. Okay. So the one which is first released is ball A. So we know the height, it's dropped from rest. Okay. So we can find h is equal to half gta. That is, we can find the time of descent of ball A, which is 2 under root 2h by g. On solving, what do we get? Time as 5 seconds for ball A to reach the ground. 2 seconds later, okay, another ball B is dropped. So the time of flight for time of descent for B will be 5 minus 2, that is 3 seconds, because both the balls reach the ground simultaneously. So the ball B has a greater velocity that it can reach the ground much faster. So since ball A is dropped from rest, it takes a longer time to reach the ground. But ball B instead, it is dropped with a velocity, certain velocity u, which we are required to find. Okay, so both the balls, they are covering the same displacement, but the time differs because of the difference in initial velocities. So writing the displacement equation for B, h is equal to ut plus half gt square. So 125 is equal to u into 3 plus half into 10 into 3 square. So from this you can find u. Solve. What do we get? U as 26.6 meter per second. So this was a simple question which is based on dropping of two balls. So when you understand this question, helps you solve problems on the similar lines. So we saw free fall motion. Now let's look at a body projected vertically upward from ground. Okay, so a body is projected with velocity u from ground, and the highest point it reaches in air, its velocity becomes 0. At any height in the upward journey, velocity can be written as under root u square minus 2gh, just by the simple formula u square minus v square minus u square is equal to 2as. Just that a little modification, we got this. And maximum height, to reach the maximum height, the time of ascent is u by g, and the total height h is u square by 2g. The time of ascent is equal to the time of descent, so the time of flight will be 2u by g. So these are the basic formulas that one knows for vertically projected body. So now let's take a scenario in which the total time of flight is 10 seconds. So body is thrown. As you can see, in the 5th second it reaches the highest point where its velocity becomes 0 and finally reaches ground at the 10th second. So here, for each of the downward motion, if you consider, its initial velocity is 0 and there is a constant acceleration. So what can we apply here? We can apply the law of odd numbers. So this distance will be x, next distance 3x, next for the next second it will be 5x, for the next second it will be 7x, and then 9x. So this x is always g by 2. The first displacement during the first second of the downward motion is always g by 2. So what is 3x now? It is 3g by 2. 5x is 5g by 2, 7g by 2, 9g by 2, and so on. So this displacements during the upward journey and the downward journey, you see, they are always equal. So please note, irrespective of the velocity of projection, displacement during the last second of upward motion is equal to the displacement during the first second of downward motion, and that is equal to g by 2. So this is a very very important concept. Please remember this. So I repeat, the displacement during the last second of the upward motion is equal to the displacement of the first second during downward motion, irrespective of the velocity of projection, that is always g by 2. Next thing you should note is, if in n1th second and n2th second a vertically projected body covers the same distance, then how will you find time of flight? It is n1 plus n2 minus 1 second. Okay, when it covers the same distance in n1 and n2 second, then the time of flight will be n1 plus n2 minus 1 second. So I'll give you a question so that you understand this better. A vertically thrown body reaches the maximum height in 5 seconds. Then the distance traveled by it are same in, the options are given, first and 10th second, second and 8th second, 4th and 6th second, both B and C. So let's find out. So what have they given? Vertically thrown body reaches maximum height in 5 seconds. So that means the time of ascent is 5 seconds. Okay. Then what is the total time of flight? 10 seconds. So just imagine the situation using this simple diagram. So 0 seconds projected upward. This is 1 second. This is at 2, 3, 4 and 5. 5th second is at maximum height. 6, 7, 8 and 9. 10th second it's coming back to your hands. Alright. So from this what do we find? For the first second and the 10th second, you see the body is at same height. The distance traveled by it are the same in first second and the 10th second. Similarly, you see second and the 9th second, the body is at same height, so it travels the same distance. Similarly, 4th and 7th, it is at the same height. So what's the correct answer? It's option A. So note, at every point in the path, the velocity will be equal while going up and while coming down. So that's it for today. I have provided the maximum number of tricks that will help you to solve questions in less time. I didn't go deep into the concept because this lesson is something that you've been learning from your 9th standard, and by now your schools and your institutions might have finished teaching this chapter. So I just wanted to touch upon those important concepts, those tricks and those hints which will help you solve questions in a jiffy, and I tried my level best in doing this. So thanks a lot for watching and keep supporting. All the very best.